everyone, welcome to our channel The Education Seeker, and this is the third problem of concept booster series, and this problem is from organometallic chemistry, and the problem is the major products P and Q in the following palladium-catalyzed diacetoxylation reactions are. So here we have the substrate molecule, that is cyclohexadiene molecule, and cyclohexadiene in presence of catalytic amount of palladium acetate, lithium acetate, benzoquinone and acetic acid is giving P as major product, whereas in presence of the second reaction condition, which is almost similar to the first reaction condition, but the difference is that only catalytic amount of lithium chloride is added. So it is giving Q as major product, right? So four options are given. Now as you can see in option A and option D, the product is 1, 2, 3, 4. That is 1,4 diacetoxylation product. And in option B and option C, the product is 1,2 diacetoxylation product. So basically this reaction is regioselective reaction, and there are two possibilities, that is 1,4 diacetoxylation and 1,2 diacetoxylation. Now option A and option D will fall into the category of 1,4 diacetoxylation, and option B and option C will fall into the category of 1,2 diacetoxylation. So if regioselectivity is explained properly, then one of this category will be correct. Now suppose 1,2 diacetoxylation product is found as major regioisomer, and if we apply stereoselectivity in the reaction, then out of the two options, that is B and C, one of the options, that is either B or C, will be correct answer. And if 1,4 diacetoxylation product is found as major regioisomer, then out of the two options, that is A and D, one of the options will be correct answer. Basically, if we apply stereoselectivity. So now we are concerned about regioselectivity as well as stereoselectivity to explain the product formation. Now let me explain the first reaction scheme where cyclohexadiene molecule is giving P as major product. Now so far the mechanism is concerned, in the first step palladium acetate, which is acting as Lewis acid, will coordinate to the double bonds of cyclohexadiene molecule and thus enhancing the reactivity of cyclohexadiene molecule towards any nucleophilic attack. Now in the second step, in presence of external acetate ion, the acetate ion will attack to the terminal end of the double bonds from the top side, and as a result of this, allylic carboanion will be formed, which subsequently coordinates to the palladium center through eta3 mode and OC minus departs. And as a result of this, pi allyl complex will be formed, and where the palladium center is ligated by benzoquinone molecule, and this step is also known as trans-diacetoxylation because the acetoxy group and the palladium are anti to each other, and coordination of benzoquinone to the palladium center will dramatically increase the reactivity, and it is converted to sigma allyl complex where palladium has acetate group, and as a result of this it will undergo cis migration, and where this palladium oxygen bond will break and oxygen will be attached to this carbon, and this bond comes here and carbon palladium bond will break, and as a result of this 1,4 diacetoxylation product will be formed where the acetate groups are trans to each other and palladium 0 will be reformed, and which is ligated to the benzoquinone molecule, and palladium 0 in presence of acetic acid will be converted to the palladium acetate where palladium is present to the palladium 2, that is palladium 0 is oxidized to palladium 2 and benzoquinone molecule is reduced to 1,4 hydroquinone molecule, and again 1,4 hydroquinone molecule undergoes aerial oxidation to form benzoquinone molecule. Thus, palladium acetate and benzoquinone are reformed in the reaction medium, and which repeats the catalytic cycle, and 1,4 trans-diacetoxylation product is formed as exclusive product. Now, one important point to be noted that AC minus, that is OAC minus, can attack to this carbon, but this attack is not sterically preferable, whereas the attack of acetate ion to this carbon is sterically preferred, and which will lead to the 1,4 diacetoxylation product, and which is the major regioisomer. Now in the second case, cyclohexadiene molecule in presence of catalytic amount of lithium chloride and the rest of the reagents will give Q as major product, and here is the mechanism, and you can see in the pi allyl complex the palladium center is no longer connected to acetate ions, because in presence of catalytic amount of lithium chloride the chloride ions will displace the weaker ligand acetate ion, and as a result of this the stronger palladium chlorine bond will be formed. And now in the reaction medium the concentration of chloride ions is very less because it is used as catalytic amount, but the concentration of acetate ions is comparatively high. So as a result of this, trans attack by the external acetate ion take place from the top face, and thereby leading to the formation of the cis-diacetoxylation product, and palladium 0 is formed, and the rest of the steps are same as the previous one. So basically this diacetoxylation reaction is ligand controlled, that is in presence of lithium chloride we are getting the cis product, but when the reaction is conducting in absence of lithium chloride we are getting trans product. So the correct answer is option D. So thank you very much for watching, and if you find something interesting then please do like, share and subscribe to our channel so you don't miss any single video, right? Thank you.